Good evening, dear students. Now I want to discuss hydrolysis of alkenes from alcohols, phenols, ethers lesson. There are three important hydrolysis reactions are there. That is acid reflux followed by hydrolysis. That is first one. Second one, oxymercuration demercuration reaction, and last one, hydroboration oxidation reaction. So these three are very important reactions. Actually, these three reactions we can learn in alcohols, phenols, ethers. Here preparations. Same already maybe you have learned in chemical properties of alkenes. Their chemical properties of alkenes here preparation of alcohols. So two times repeated. This is very important for NEET aspirants and JEE aspirants also. Now first one, acid reflux followed by hydrolysis. This reaction follows electrophilic addition mechanism. So here mechanism, electrophilic addition mechanism. Rule, Markovnikov's rule. You know, rule is first or concept is first. Concept first. Rule means that is simplest way. So clear, here electrophilic addition mechanism it follows, but rule, Markovnikov's rule, but with rearrangement takes place, because here intermediate is carbocation. You know, in any reaction carbocation intermediate is formed, then definitely we can do possible rearrangement for getting stable carbocation. So now here this is the alkene and hydrolysis presence of acid. Now mechanism. So what is the major product here? Now I am writing mechanism. So this is the alkene, CH double bond CH2. Already I told you it follows electrophilic addition mechanism. If any addition reaction is initiated with electrophile, this is addition reaction, it is initiated with electrophile. That's why it is electrophilic addition mechanism. So multiple bonded compounds, double bond or triple bonded compounds involved in addition reaction, it is initiated with H plus, that is electrophile. That's why it is electrophilic addition reaction. So now CH, here CH3, here carbocation generated. So now carbocation is connected to how many carbons? Yes, this is one carbon, this is one carbon. So it is secondary carbocation. Now, how many hyperconjugated structures are there? Here, this is alpha, this is alpha. You know, here one hydrogen is there. So here one alpha hydrogen, here three alpha hydrogen. So total how many hydrogens? Four alpha hydrogens. So four hyperconjugated structures. Now, you can do hydride shift. You can do hydride shift. You can do hydride shift. So now, shift, hydride shift. So clear? Now which carbocation generated here? This hydride ion shifted to here, CH2, it will become CH3. Here carbocation existed. Now carbocation, it is connected with how many carbons? 1, 2, 3. 3 carbons means it is tertiary carbocation. How many hyperconjugated structures? Alpha, alpha, alpha. So here 2 hydrogens, here 2 hydrogens, here 2. So 6 hydrogens, 6 hyperconjugated structures. You know, more hyperconjugated structures, more stable. So this is more stable. It is more stable. You know, this is less stable. Okay, dear students, very important point. Always product is formed by a stable intermediate. Okay, always product is formed by a stable intermediate. So now here from water, because this is hydrolysis reaction, so water is available. So you can add here OH minus from water. From water you can add OH minus. Then which product is formed? Okay, this product is formed. This is major. Okay, this is the major product. Understood? Simply, I wrote one sentence. It follows Markovnikov's rule with rearrangement. Why? So here carbocation intermediate is formed. That's why hydride ion shift takes place. Now, usually here OH minus ion added to internal carbon, less hydrogen containing carbon-carbon double bond, internal alcohol. But actually here tertiary carbon that OH minus added. So rearrangement takes place. That's why simply I gave one sentence, that is, it follows Markovnikov's rule with rearrangement. Understood? So not only here internal alcohol formed, and here rearrangement takes place. So because it is electrophilic addition mechanism, so we have to check which carbocation is more stable. So very important electrophilic addition mechanism. So Markovnikov's rule with rearrangement. So this is one important reaction. So now move to second hydrolysis reaction. Here, oxymercuration demercuration reaction. Remember, this reaction follows Markovnikov's rule without rearrangement. So very simplest reaction it is. Here mechanism not required, but before reaction, acid reflux followed by hydrolysis, their mechanism required. But here, no mechanism required because there is rearrangement takes place. Here, no rearrangement. So this reaction follows Markovnikov's rule without rearrangement. Now, a reagent is water. Negative part of the reagent, okay, negative part of the reagent added to less hydrogen containing carbon-carbon double bond, means internal carbon. Positive part of the reagent added to more hydrogen containing carbon-carbon double bond. Then simply internal alcohols formed. Here no rearrangement, just internal double bonded carbon. You can add negative part of the reagent. So now here answer is here OH you can add, here hydrogen you can add, just internal alcohol. So this is the major product. Here mechanism not at all required. So negative part of the reagent you can add to less hydrogen containing carbon-carbon double. Simply internal carbon. Positive part of the reagent to terminal carbon. That's all. Now coming to third reaction, hydroboration oxidation reaction. Here reagents BH3, THF, H2O2, OH minus water. Here reagent is water. This is the reagent. These are all hydrolysis reactions. Now this reaction follows anti-Markovnikov's rule without rearrangement. Clear? Without rearrangement. Anti-Markovnikov's rule. Understood? So it follows anti-Markovnikov's rule. Cross effect, okay? Peroxides effect, another names. So now, so here also no rearrangement. Now, anti-Markovnikov's rule means, negative part of the reagent added to terminal carbon of carbon-carbon double bond. Positive part of the reagent, internal carbon of carbon-carbon double bond. So that means a negative part of the reagent. Here main reagent hydrolysis reaction, water is reagent. So negative part of the reagent is added to more hydrogen containing carbon of carbon-carbon double bond. That means terminal carbon. Positive part of the reagent is added to less hydrogen containing of carbon-carbon double bond. That means internal carbon. Then simply here without rearrangement the product is formed, that is terminal alcohol. Which alcohol is formed? Terminal alcohol is formed. Here hydrogen, here OH. So simply terminal alcohol is formed. Understood everyone? These are the three hydrolysis reactions. First one, acid reflux followed by hydrolysis. Markovnikov's rule with rearrangement. So second one, oxymercuration demercuration reaction. Markovnikov's rule without rearrangement. And last one, hydroboration oxidation reaction. Here reagents BH3 and THF. THF means tetrahydrofuran. Solvent, that is. BH3 means that is diborane. Diborane its monomer BH3. So H2O2, OH minus water. These are the reagents. When you will see these reagents, yes, you have to understood. Yes, it is hydroboration oxidation reaction. So it follows anti-Markovnikov's rule without rearrangement. Just terminal alcohols are formed. Understood? I hope everyone understood this session. Thank you. Thank you so much.